Okay, on this video we are going to practice on proposing the correct particular solution. Okay, so we are going to see now, we have seen the polynomials, the sine and the exponential. So what we are going to see is how to propose particular solutions when we have combinations. And combinations, I mean an exponential times a polynomial, an exponential times a sine or cosine, a cosine times a polynomial, and then finally a polynomial times the exponential times the sine. That's that kind of combinations. All right. Again, these undetermined coefficients only works for sine, cosine, exponential, and polynomials and combinations. All right. Another kind of function, it doesn't work. To solve that, we are going to see another method. But let's focus on proposing the correct particular solution. By the way, this is 5. And this is 5. Okay, now, the first one are very easy. This is a polynomial of second degree. So your particular solution must be a polynomial of second degree. Now, usually the students do this. Ax squared plus b, and that's it. Okay, because it's very similar. However, when you write the particular solution of the polynomial, what you have to do is to write the full polynomial. And when I say the full polynomial is this. Now, this is incorrect. It's very similar. You have a 3x squared and then the 1, the independent coefficient, but you have to write the full polynomial. And that means ax squared plus bx plus c. And this is the full polynomial of second degree. Alright? Even though you don't have x here, that doesn't matter. You have to write the full polynomial. Okay, now, for example, this is x to the power of 5. And you don't have x to the power of 4, x to the power of 3, x squared. You only have x, and that's it. And the students usually make the particular solution as only ax to the power of 5 plus bx, and that's it. Well, that is incorrect because you have to write the full polynomial. And the full polynomial of degree 5 is like this. X to the power of 5, then x to the power of 4 plus abc x to the power of 3 plus dx squared plus abc de x plus f. Alright? So let me write here the takeaway here. Write the full polynomial. Please don't make that mistake because it's a very common mistake. Okay, now on the sine and the cosine, well, the particular solution will be from here is going to be a sine of 4x, but you have to write also the cosine. So plus b cosine of 4x. Okay? So that is a proposed particular solution. Now, what if you happen to have plus cosine? Now, it is different. The argument is different. Alright? So this that is totally different. So the particular solution should be plus c, the cosine of x only. And then because you have the cosine, you have to also write the sine. Plus the sine of x. Alright, so whenever you have the cosine, you have to write the cosine. Whenever you have the sine, you have to write both. Now this sine and these cosines, they are different because they have different argument, so they are treated differently. Each one of them has both the sine and the cosine, and here the cosine and the sine. Okay, so that is the example for that. Now on the exponential of 5x, well, we have seen that. So the particular solution is just a exponential of 5x, and that's it. Now, if you happen to have another polynomial, let's say you have plus 3 exponential of minus x, then you have to write plus b exponential of minus x. Alright? Now, engineers, just because you have a 3 here, it doesn't mean you have to write 3 here. Alright? Just because you have here 3 doesn't mean that you have to write 3 or whatever number you have there. No, you have to write just the coefficient, just like that, alright? The value of A may be 3, but we don't know. And because we don't know, we cannot assume that you have a 3 here, alright? Okay, now, the first combination, you have a polynomial and a polynomial and exponential, the polynomial of the first degree. Okay, so the particular solution will be something like this. The particular solution is just the combination is going to be ax plus b for the polynomial, and then the exponential of 5x. Alright? Now, some students in the past I have seen that they write here another constant, c, in a multiplication. Well, that is not necessary, because if you multiply the constant times this constant, still they are constants, so there is no need to write a constant there. So the constants for the exponential is already here, right? And here you have a multiplication, because here you have a multiplication. Okay, that was very simple. But what about this x to the power of 3? Because you have a polynomial of third degree and the exponential. First of all, the particular solution, you have to write the full polynomial. Ax to the power of 3 plus bx squared plus cx plus d, and then exponential of x. Alright? So that's, you have to write the full polynomial and the exponential. Now, what about the exponential with the combination with the cosine? Here, remember, it's here we have a multiplication. Okay, so the proposed solution will be something like this. The particular solution is going to be very similar to the polynomial and the exponential. Here is going to be a cosine of 2x. Because you have the cosine, you have to write also the sine, plus b sine of 2x, and then times the exponential of 3x, sorry. Okay, so that is the proposed solution. Because you have the cosine, you have to write also the sine. And both are multiplied times the exponential. You can write here the exponential and here the exponential. I decided to factorize it. It depends on you. Okay, now you have a combination of a cosine and the polynomial. So here the particular solution is going to be tricky and very long, by the way. You have to write the full polynomial. Because it's a second degree, then it is going to be ax squared plus bx plus c, the cosine of x. And be careful here, because you have the cosine, you have to also write the sine. And because it's a sine, so you have to write again the full polynomial. abcd x squared plus abcd x plus f times the sine of x. So this should be a very long problem, because it is 6 coefficients. It's going to be very, very difficult problem and very long problem. But my point here, engineer, is having the correct particular solution is the key to have right the solution. Finding the coefficients, it is talacha. It is just algebraic steps. But having the correct particular solution is the key. So again, the cosine and the sine, and both with a full polynomial. Full polynomials of x squared. Now, same story here, but you have now an exponential. So the particular solution, this is going to be long, so I'm going to write it from here. So my particular solution is going to be, because it is x squared, so it's going to be, and I'm going to make a corchete here, it's going to be ax squared plus bx plus c, the sine of x, and because we have the sine, we have to write the cosine. So, and again, full polynomial, abcd x squared plus x plus f, the cosine of x, and then here the exponential of x. Okay, this will be a very long problem to solve. And when I say very long problem to solve, is because to find the coefficients, what you have to do is calculate the first derivative and the second derivative. And taking the derivative of this is going to be very long because you have multiplications, right? And you have, again, another multiplication here. So that is very, very long problem, okay? But this is just example. Okay, so with this, this is the example of how to propose the particular solution with the combinations. I didn't do an example of this when you have combinations because they happen to be very long problems and I don't have enough space on this whiteboard. So please check the homeworks or the homework solutions where I have examples of these kind of problems. See you next video. We are going to finish the undetermined coefficients method.